When a critical vehicle or piece of equipment goes down in a contested zone, waiting 6 to 10 weeks for a replacement part isn't an option. It puts soldiers at risk. On today's battlefield, every hour a vehicle sits idle is the difference between mission success and mission failure. Imagine this scenario. A U.S. Army mine-resistant ambush-protected, or MRAP vehicle is deadlined just across the border in a hostile, dense urban area. Back at the forward operating base, the crew knows exactly what's wrong, but they don't have the part, nor does the nearest logistical base. The standard response? Order the part from the OEM. Once available, it ships from the United States. This translates to weeks or more for the part to arrive in theater. It arrives at a major base, then moves by helicopter to the forward operating base. From there, there's no Uber or DHL to get it to the end user. A convoy of vehicles is assembled. Each one carries 3 to 5 armed soldiers. The path takes them through the red zone, a dangerous boxed-in area that can quickly turn into a killing field. All of that risk, all of that cost for one metal part. This scenario is based on real experiences from the Tennessee Army National Guard. Recognizing the need, the U.S. Secretary of War directed the Army to expand advanced manufacturing, including 3D printing in operational units by 2026. The DEVCOM Army Research Laboratory, the University of Tennessee DARC, and the Tennessee Army National Guard took up the challenge and delivered ahead of schedule. Together, they joined forces with SPEE3D to demonstrate how expeditionary manufacturing can bring production power directly to the front line and avoid the delay and the risk we so often see in the field.
This is the first unit in the entire Army, the Tennessee Army National Guard, to be able to embed this capability, and then for this demonstration be able to show how we can come together as a team between the Tennessee Army National Guard, the soldiers that will operate the equipment, our great SPEE3D partners, and our university researchers to build a relevant part, and then to use drone technology to fly it to a broken down vehicle that needs that critical part, to repair that vehicle, to bring it back to safety.
Inside SPEE3D's Expeditionary Manufacturing Unit, the EMU for short, a soldier loads powder, sets the substrate, and initiates the print. In minutes, the printer, using cold spray technology, begins building solid metal layer by layer without melting, without waste. No factory, no long supply chain, just a deployable unit manufacturing what's needed where it's needed. For this live demonstration, the team focused on a small component with massive consequences: the combat lock handle for an MRAP maintenance support vehicle. If it fails, the door can be pried open from the outside, opening the vehicle to attack. Without this part operational, the vehicle is deadlined, stuck in the field, unable to return to base.
For the demonstration, we've made the battle lock handle for an MRAP vehicle. Traditional military vehicles do not have push-button locks like the cars we're used to. This actually engages a huge latch that secures that door in place. And if it's missing, broken, or faulty, it actually deadlines the vehicle and we can't use it. For the trial, we scanned, drew up, and designed and printed the replacement for it. When we were making these, it was super simple. The print time took about an hour and a half to make it in stainless steel. Once you factor in the heat treating and the machining, it was 10 hours or less, which may sound like a lot, but that's a lot better than waiting 10 weeks for this part to get delivered to me to get a vehicle back on the road.
Instead of a convoy pushing through a contested urban corridor, the team chose a different route: airborne. In this live mission scenario, a drone carried the newly finished EMU part over a remote, undrivable terrain outside of the urban area directly to the stranded vehicle. A 6-week logistics chain became a single-day mission. This demonstration showcased how soldiers can retrieve the printed part, repair the vehicle, and drive home on the same day. Proof that with point-of-need manufacturing, downtime and risk to soldiers can be drastically reduced.
Having the capability to produce this part on site would have a lot of positive effects on things like soldier safety, mission capabilities, survivability of vehicles, decreased time as far as BDAR, battle damage assessment and repair of vehicles. It would drastically decrease wait time, cut down on safety risk and mission capability.
When we talk about the cost of a part, It's not just the price on the OEM invoice. It's aircraft hours, helicopter missions, convoy planning, fuel, maintenance, and manpower. It's weeks of lost availability and the risk to every soldier who rolls through a contested zone to deliver a piece of metal that could have been printed on site. With Expeditionary Manufacturing, the Tennessee Army National Guard, DevCom Army Research Laboratory, and the University of Tennessee DARC proved there's another way, one that's faster, safer, and more cost-effective. And it didn't stop at a single handle. The soldiers and researchers used the EMU to produce multiple parts that directly impact survivability and readiness.
The reason for the demonstration, again, that this is cutting-edge technology. It's new to be able to take cold spray technology and build 3D repair parts. We've built a cover, an exhaust cover from a 3kW generator out here that goes to a medevac vehicle that powers the medevac equipment for that vehicle. That system was down until we built that with the cold spray system. So that will save lives.
Throughout the demonstration, the Tennessee Army National Guard also printed mounting brackets for a ballast screen that shows where friendly forces are on the battlefield, critical hardware for preventing a friendly fire incident. Traditionally, when these brackets break, units order an entire assembly worth thousands of dollars just to harvest the brackets and then are forced to store the remainder of the unneeded assembly in already limited storage space where those parts may never be used. With the EMU, they simply print the parts they actually need.
During this trial, I was introduced to technology that I didn't even know was out there and available to us. I had a very short amount of time and training with this, but even with that, I feel like I could take this back to my unit, train my soldiers how to print our own parts right there on the fly. I think it would just be a game changer for us.
This isn't just equipment. It's a capability soldiers can learn quickly, own, and integrate into their daily operations. It's a force multiplier in a box, putting production power in the hands of the warfighter.
Our next steps, again, we're big on expeditionary manufacturing. We want them to be more combat ready, increase their mission readiness, and most importantly, save lives.
Together, the DevCom Army Research Laboratory, the University of Tennessee DARC, the Tennessee Army National Guard, and SPEE3D are redefining readiness. They're proving that you can print the parts that keep soldiers safe where they are, when they need them, wherever the mission takes them. SPEE3D, expeditionary manufacturing, proven, deployable, ready.